Hey everyone, and welcome to this newest edition of our community call, and it's actually the last one of 2024. We hope you've had a good, we'll say, fall and early winter that's starting up right now, and are looking forward to a great 2025 that's not too far away. My name is Rob Dominguez. I'm an engineer here at Hasura, and I host the community call. In just a minute, I'm going to go ahead and share my screen, kind of give you an agenda and an overview of what we're going to be looking at. If this is your first time joining us, then welcome. If it's not your first time, you're probably familiar with the fact that we change platforms somewhat frequently. This is a new one for us, but we're very excited about it. So please give us your feedback about what the experience for this community call is like as we're going through things today. Let me go ahead and share my screen with everybody, and let's get going. All right, so here's our agenda today, and as usual, it is packed. We're going to be talking about PromptQL as our primary feature. And to begin with, I'm going to bring on our product manager for PromptQL, Anusha Gupta, who's going to talk about our product updates that have come through. So you've got some product updates for us that you're going to talk about, yes?
Yes, I am. Yeah.
All right.
For those who have not seen PromptQL before, PromptQL is this new product offering by Hasura. If you just Google PromptQL or go to promptql.hasura.io, you'll see what PromptQL is about. It's basically a data access agent for you to build really powerful AI assistants and agents on your data. So basically, Hasura has been around for a while, and they have been solving the data aggregation, data retrieval problem well for a while. And Hasura has this unified metadata layer, unified a semantic metadata layer, which allows you to have this universal data access layer across all your data sources, be it structured databases, SQL, NoSQL, be it vector databases, SaaS applications, APIs, custom business logic. And Hasura gives you a GraphQL or REST API on your data, right? So we thought that can we do the same but for AI? Because right now the reason why AI is not so common in our day-to-day use cases is because AI is not able to access data on the fly, come up with dynamic query plans and access data on the fly based on the user's requirements. And that's what we wanted to build with PromptQL. So what you see here is PromptQL in the Hasura console, in the DDN console. It's a new capability on the left navigation bar that you can see now. It just works out of the box. To set up PromptQL, once you're done setting up your DDN project, you just go to Settings, PromptQL, enable PromptQL, select your LLM provider, give us the API key for the LLM provider that you want to use, and you just start using PromptQL. So let me just quickly run through one query just to show you what PromptQL is all about, and then I'll share some product updates on PromptQL. So this assistant just showed in the last community call, which is built for our customer support team, connected to our user data, our product usage metrics, our finance and billing data, and our ticketing system, which is Zendesk. So if I ask, in the last community call, I showed a way to ask very structured questions. What I wanted to show this time was the ability to ask a very vague question and continue very deep analysis on your data. So if I ask a question like, who are my 5 most favorite customers? I haven't asked this question before. I hope this worked. So if I ask a question like, who are my 5 most favorite customers? So it doesn't just start answering the question. It thinks first. Okay, for probably you want to look at valuable customers. So I'm going to find customers based on their total revenue, from the invoices, from the project activity, from the length of the relationship, how long they have been customers, things like that. So these are the metrics I'm going to include to do my analysis and find your top 5 customers, and combine all of these metrics, create a ranking, and share the results with you. And that's what it's doing behind the scenes, which is executing this query plan, implementing and executing this query plan. And if messes up somewhere, it realizes what the issue is. It can come up with an alternative plan of action, look at what's available to it, what are its capabilities, and then come back with a new way to implement and execute this. So as this runs, the first thing I want to talk about was the ability to The fact that we have this new feature called explanation. So where once PromptQL executes on something, I can ask for an in-depth explanation on how it did and what it did. So see, I have the results, right? The top 5 most valuable customers based on these metrics. Now, if I just click on this button called Ask for Explanation. So what it'll do is it'll make PromptQL run each step in the query plan one by one, and then store the artifact of each step, and then give me an answer. So here, as you can see, first thing it does is the customer revenue data. That's the first thing it does. It stores the customer revenue data as an artifact, tells me like this is the first step I ran. The second is number of projects, then the number of API requests. So it tells you very fine grained how it's doing, and then it tells me, okay, now how I calculated this metric of coming to the final customer ranking is based on these weights that I've assigned to the different metrics. So this is what makes PromptQL so powerful, is the level of transparency and explainability that you have when building these kinds of AI assistants and agents. So PromptQL broke down the steps into 3 different steps and very explicitly told me how it performed the calculation. So you don't have to use this button. You can ask for your own explanations in your language, and you can be sure that PromptQL will provide you those. So that's the first product update that I wanted to share. The second is the fact that now PromptQL assistants can be shared publicly. You don't have to be on the DDN console to work with PromptQL. So let's say you have made an assistant for your internal teams and you want to share it with everyone. You don't expect everyone to bring their own API key and set up their own projects, right? So what you can do is just go to settings, PromptQL, click on enable public PromptQL playground. Once you click on enable, you'll have the public URL for the specific assistant that you are using. It will use the same API key as the one you are using, and as well as you can set usage limits, both per user token usage limits and per project token usage limits, and that will help you make sure that no one takes advantage of your assistant. So that's another great feature. So if I, let's say, click on this button, this is what a public PromptQL looks like. So I have this assistant now. A great thing is you can also add a README to it. So if you add a README, you can just share with people the context on how this assistant was built, what questions you can ask, what data is it connected to, and things like those. So now this helps you just build these super powerful assistants and share publicly very quickly. The third thing I wanted to show is a new primitive we have called the extract primitive. So if I just go back to my assistant, and if I ask something like, in the last 10 support tickets, extract the Hasura version they are on. We have 2 versions, V2 and V3, which is also called DDN. Make sure you use the extract primitive to do this, so that I make sure that it uses it. So what the extract primitive does is, so as you know, PromptQL writes these query plans, implements these query plans, and executes these query plans. What these primitives allow you to do is allow PromptQL to have much deeper semantic capabilities and to apply semantic logic on the fly iteratively on any amount of data that you might ask. So if I, let's say, if I wanted to analyze 10,000 support tickets, PromptQL will not pull those 10,000 support tickets into its own context and answer your question, right? What it will do is it will delegate this task to another LLM. So extract is one of those kinds of primitives. So if you look inside, what it's doing is extract basically gives instructions to the to an LLM that, hey, can you do this based on this content, based on this input, and store it in this kind of a JSON schema, and provides a JSON schema to it. Okay, I want you to extract a string out of this data, where the string is either V2 or V3 DDN. If the version cannot be determined, use unknown. So that's how you can do these kinds of extraction tasks, where you extract structured data out of unstructured data, like this. Interestingly, the last 10 tickets mostly were about V2. So that's the third new capability that PromptQL has. One final thing is on design, which is PromptQL is now mobile responsive. So if I resize my screen, I hope this works right here. Okay. If I resize my screen, this is what PromptQL looks like on mobile. You see how you can still ask any questions you want. You can still look at all your memory artifacts. They all appear perfectly well. And then you can look at all your threads. And then, of course, the rest of the Hasura console. So that is that. These are the latest things with PromptQL. Go check out PromptQL. Go to promptql.hasura.io. Build an very powerful and interesting AI assistant right now on your data. Back to you, Rob.
Awesome. I'm going to keep you on for just a minute because we have a few questions that have come through over here on the chat, and we've been very vocal over on the chat as well. I will say, just as like a little side note, right? We have a Q&A feature as well, folks. So if you want to kind of save it for the end of the segment, what we'll do is every time a speaker comes up, you can throw your question in the Q&A, and then we'll have a discussion with the presenter as well. So just a few things that have come through that don't seem quite in at this point. Anusha, we see, can we use PromptQL for synthesizing data? So for example, if we want to instruct a set of large language models to generate factual structured data, can that be done?
Yeah, so at the end of the day, PromptQL is itself not an LLM, right? So you bring the LLM that you want. So you can ask PromptQL to do whatever you want, depending on, as long as it's inside the guardrails that we have set up. So yeah, you can ask PromptQL to generate data. You can ask PromptQL to generate data which fits your schema, because PromptQL understands your schema. And then you can save that data as one of these artifacts that you saw on the right-hand side. And then you can download those artifacts as you want as CSVs, or copy those artifacts and use it however you want. Yeah.
Bottom line, it's still an LLM under the hood. So anything an LLM can do, it can still do as well. Yeah. Before we shift gears and go to the next segment, I'm just curious because you've had a lot, or actually, sorry, there's a little bit more that's come through. Awesome. So we can see, how does it know which parts of the metadata across all the data is most relevant to use in the queries? That's a great question.
Yeah, for sure. So I'm assuming you are already familiar with the supergraph concept at Hasura. I can quickly explain that. So Hasura DDN provides you with this unified semantic metadata layer, which we call the supergraph. Which basically is this semantic schema across all your data sources, which has not just the individual structures of your data sources, but also relationships across data sources, all the permission rules, access control rules, and things like those. So what PromptQL does is it takes your user query, it takes the supergraph, and asks the AI, what do you think would be the most relevant data source to answer this query? One or multiple data sources. How would you, if you were a human being, how would you come up with a plan of answering this question by fetching data from these different data sources? Just come up with a plan, don't do it. That's the query plan that you see. And once we have the query plan, it's very easy for us to implement that query plan and execute that query plan. So it's at the core.
Yeah, I was going to say, so at the core, really, what unlocks PromptQL's potential is the idea of DDN provides, which is that semantic metadata layer, which essentially is a very human readable and also machine readable. We see description of how your API kind of all fits together, right?
Yeah, exactly.
Yeah. Awesome. All right, Anusha, thank you so much for coming on today. We do have one more question, sorry, and then we're going to shift over. Sorry, could that question pop back up? Was that it jumped away for a second? If PromptQL in SQL and not GraphQL queries to access data and functions, how do you handle permissions in calling business logic? Great question.
Great question. So first of all, the SQL that you see PromptQL writing is not the SQL that is directly executed on your data sources, right? What if you have Mongo under the hood, right? SQL won't work. What if you have an API under the hood? A SQL won't work. So SQL is just a way to express data requirements. It's not a way to execute data fetching calls. So just how GraphQL is a way for your front-end engineers to express data requirements, and that GraphQL is executed on the Hasura engine. And we take that GraphQL, we apply all the same permission access control rules when it's been executed on the Hasura engine, and the Hasura engine translates that into the underlying data sources native queries. So that's what SQL is. That's what the SQL architecture is also doing. SQL is this Turing complete language which has been out for the last 40 years, which LLMs are really good at generating. So SQL is just used to generate that data requirement queries, and that SQL is given to the Hasura DDN engine, and that DDN engine slaps on the access control and permission rules, and then executes the data requirements on the underlying data sources.
Kind of a follow-up question for me, just to kind of round out clarification for all of this, right? So we understand why SQL is being used. Is that also why Python's being used to essentially write these queries, for lack of a better term?
Yeah. So think about what kind of operations you want to do, right? There are three. If you can bucket all the operations in the world in three categories. One is data retrieval operations. Second is computational analysis operations. The third is semantic operations. So what is great to represent data requirements? SQL. What is great at representing analytical and computational requirements? Python. What is great at representing or doing semantic operations are LLMs. So that's why we have SQL, we have Python, and then we have primitives. The primitives can call LLMs. Yeah.
Gotcha. All right, Anusha, thank you so much. For anybody that had questions in the chat that did not get answered, Anusha will stick around for a little bit backstage, and he'll answer those questions in the chat over on the right-hand side. So have a great day, and thanks so much, man.
Thank you so much, folks. Thanks, Rob.
Yeah. All right, just to avoid any kind of possible issues with screen sharing again, I'm not going to share mine for the next segment. I'm just going to go ahead and read it out loud. We're going to shift gears, and we're going to bring on Tiru in just a moment. And for anybody that's a long-standing community member that's been here really since like the first days of Hasura, you'll remember Tiru. I don't think we've had him on the show in quite a while, though. But we're going to be talking about the battle of what we're calling the AI Titans. And we're going to take a look at Salesforce Einstein and pit it up against PromptQL. So Tiru, will you join me on stage, please? I'm going to step out the way and just turn this over to you, because I know we're going to take a look at some cool stuff while we pit PromptQL up against Einstein and see who's smarter.
Hey, folks. So basically, you saw what PromptQL is. You got a taste of like the features it has and the architecture where it's built for reliability, repeatability, and explainability. But let's look at how it compares with something else, right? Something that are supposedly state of the art. So we picked few products, very good products built by like extremely popular companies. Today we'll talk about how PromptQL fits with Salesforce Einstein on Salesforce data. So Salesforce Einstein comes with their whole LLM AI intelligence suite, and they have integrated it in their Salesforce application as well. So we use that, and then we also connected PromptQL to Salesforce through a Heroku connector, which they provide. So that gets you data to any database that you want. So it was easy to like set it up with PromptQL. So let's see how that fares. Before that, I just want to share this snippet from Mark Benioff, who's the Salesforce founder, CEO, a very popular guy, who commented this about Microsoft's Copilot, and generally he was lamenting about so much noise in AI and the agent ecosystem. Right, you hear about AI agents taking over everything, but Mark Benioff basically said that companies lack the data, metadata, and security models to actually incorporate real intelligence. Copilot is inaccurate, spills corporate data, and forces customers to build their own LLMs, almost like Clippy 2.0. Although I did like Clippy when I used to use it. But Agent Force is transforming businesses now. Agent Force does a lot of cool things. So we thought, okay, let's see how well it does. So without further ado, let's go. So round one, we'll start off with a very simple, straightforward question that you would ask any sales, like you as a salesperson, sales analyst, you would ask this question: what's the average length of our sales cycle this quarter? Right? You can see the question here, and Einstein actually says that it's unable to access necessary functions to retrieve that information, which is very weird because it's asking about sales. And then sure, it's an AI, it's an LLM. You have to sometimes you have to coax it, you have to ask it again. So if you ask it again, it quickly computes something and tells you the average length of our sales cycle this quarter is 2.21 days. That's impossible. Like it takes 2 days to just meet a prospect. It doesn't close in 2 days. So this is obviously wrong. So let's look at PromptQL now. same question, and you can see that it creates a query plan, so you have like good explainability of what actually went under the hood, and it comes back with an accurate date. Actually, this is pretty much close to what you typically see in a company of our size dealing with large enterprise and so on. It takes about 7 months, right? So you can analyze the data, you can look at how it got to this data, what it computed, and you can be very sure of this number. So that was round one. Round two. Again, pretty straightforward question. I think these would be the first questions that you would try in any sales assistant. Give me the top revenue customers we closed last quarter. And Einstein again seems to have no records matching that query. How could Salesforce not have top revenue customers from last quarter, right? We asked the same question here. Very quickly, have to blur these names because it's actual data. So, but you can see that it returns about 20 rows and tells you how it got there. Much of what you would expect a good AI assistant to answer. Round three, right? Question is summarize any action items or next steps for a particular prospect. I mean the name of the prospect here. So every prospect goes through a lengthy sales cycle, right? So there are a lot of input inside a prospect's record. So you want to quickly know the action items there. So when you ask this question, Einstein actually does respond with something, but you have to look carefully to see what's this actually answering. So it goes through the activities up and summarizes any action items or next steps. First, it tells me about this prospect, which I did not ask. Uh, then it tells me some more information about this prospect. Tells me about cases. Tells me about the activities. Now, this was what I was interested in. So, it just tells me the recent activities include like multiple email exchanges and meetings related to Hasura collaboration. Future tasks and events are not listed. That is going to be not true, as we will see shortly. And all it says is like, oh, there were few email exchanges and meetings related to this company. Tells me a few other information which is not relevant, and that's it, right? So it gave me an answer, but it did not actually satisfy my goal. But if you ask the same question to PromptQL, you would see that it creates a query plan, and it's actually a more accurate and like more detailed query plan. As we saw earlier in Anushrut's presentation, that you can extract things, you can classify things. There are ways to use language models inside this query plan itself. Like imagine like getting some data and doing heavy AI related computational stuff on that data using calling your AI and then proceeding with the remaining calculation, right? So this kind of composition is possible in PromptQL. And that is why if you see this, you see a much more detailed, much more aligned with the question that was asked. Like it's a very detailed and aligned answer to what you expect. And it tells you like what has happened, and it tells you the immediate next steps, which is to follow up with the POC results. Round four, we'll first ask PromptQL here. What opportunities are set to close this fiscal quarter? And I've defined the quarter here. In Hasura, we have quarters like little bit like 1 month shifted and so on. So you have match the calendar quarter. So you have to tell what the quarter means. So I've defined it here. And as you can see, you do get like opportunities which are from the ending of January, because that's this quarter, November, December, and January. So you can see that the results are there, about 60 results. Same question, if you ask Einstein, you don't even get anything in January. In fact, you don't even get anything in the middle of after the middle of December. I think that is because it doesn't give you anything more than 50 rows. That is my sense. But then you could ask it, right? Like, fine, it may be limited the result set to 50, but I want the rest of them. So you can ask it. Are these all? It says yes, these are all. So that is what is the issue. right? If it tells you that these are all the prospects that are there this quarter and it missed like a good 10 of them, then you're not going to be able to do your analysis very well, right? Round five, which is the final round. And this is a very hard question. And I actually don't expect any sales assistants to get it quickly, get it right, get it quickly, uh, and be very satisfactory. But let's see. So, extract any common identified pain points for all ops that were closed lost last quarter, and follow this process. Like I'm steering the assistant to do the following process. Like get each opportunity that was closed last quarter, extract all pain points mentioned from the record. So closed loss means that you did not win that opportunity. So there should be some pain points mentioned. And then collect all the pain points and create a summary of top 5 pain points. Very useful question, but as you can see, very hard as well. So what Einstein does says that it's going to do all this. Basically, copied my prompt again, uh, and it says summaries of the identified pain points for the opportunities that were closed lost last quarter were. It just gave me 5 opportunities, and it gave me some details about that. Like it took 239 days, it took 46 days, took 232 days, and so on. So it took 5 opportunities, and it just said like how long it took to close the deal. But it's fine. Like I don't expect like this level of accuracy from any assistant, except for PromptQL, where you can see that it creates this query plan, goes through a bunch of retries also. But at the end of it, it tells you what is the time period, how many closed lost opportunities were analyzed, 138, which is the truth. There was so many opportunities. And then the summary is also exactly as you would expect. Like no decision, lost champion, no budget, delays, product related issues where you can dig deeper into this. But all of this is happening because PromptQL is able to create a plan according to the process that you've defined. And that is where our query planning approach and the steerability, like being able to edit that query plan and getting exactly what you want is possible, as opposed to just following like a set of canned rules, right? So, and this is the power of PromptQL, where you can generate like complex query plans and edit them and see them achieve your goals. So final side, like no questions asked, hands down, PromptQL is the winner. And I would like this could be like you might feel like, okay, this was just a bunch of slides and you cannot actually test this out. But I would urge you all to like go to the quick start, try this out on GitHub, and you can try this out on your Postgres database and any other connector that Hasura has, and just try to pit that against any other solution. And we'll love to hear like how your results were. And with that, I think I will close.
Harsha, or not Harsha, sorry, Tier, thank you so much. That was awesome. I know we're going to be looking at a couple of other use cases in just a moment. One's going to be a personal finance PromptQL application, and one's going to be health-related data from Apple Health. I'm curious, though, like from your perspective, especially because as we talk about LLMs, right, and this is a personal opinion, I feel like the greatest benefit that LLMs really give in terms of agentic access is being able to really analyze and synthesize data. So what other use cases have you seen in terms of looking through and retrieving like a lot of information and being able to kind of get a summary of it that you're excited about, or use cases that you think are going to be really valuable?
I think as a human being, you have to do like repeated tasks again and again over a large set of data, right? For example, for a sales analyst or you're a salesperson, right? So you have to go and look at maybe like 20 opportunities every day and see what state they are in, or like what are they blocked on and so on. So the ability to like quickly say that, hey, do this one task, but do this way, but for like 100, a set of like 100 objects, right?
Scale.
And scale that, right? Just define your plan and then just scale that out and get that result reliably in front of you will massively make you like 100x better at whatever you're doing. So I think that's going to be a killer use case.
This makes me want to also start playing around with like Giphy's API and bring that in as a connector, because your meme game or your GIF game was it was on point. Well done, sir. So great part of the deck. Yeah. All right. Thanks so much, man.
All right.
All right. So as I alluded to, we have two sections of the call left, and we're going to be looking at a couple of use cases. They're both going to be from internal. We had a hackathon where we were trying to build out with PromptQL and come up with some really cool experiences. The first we're going to look at is going to be a personal finance application. And again, that theme of synthesizing and analyzing a large amount of data and really pattern recognition is going to be a big piece that we see. And I think that'll even be true in the last one that we have. The first one that we have coming up is going to be, like I said, personal finance. It's going to be from one of our engineers in Australia, Daniel. And it's almost 4 a.m. if my time zone math is correct. So we have a recording from him.
Hi everyone. I'm going to give a short demo of how you can use Hasura's new AI feature, PromptQL, to provide insights into your home finances. PromptQL is our new AI chatbot feature that lets you interrogate and work with your data in Hasura DDN. If you want to give PromptQL a shot, you can check out our PromptQL docs, which is promptql.hasura.io, where we have a getting started page. If you've already got an existing project, we've also got a page in here that tells you how to enable PromptQL for your existing project. In my project, I have a very simple setup that I use to track my home finances. I have a transaction model which captures financial transactions. If we go to that, we can see that each transaction has a date, a description, and an amount. You'll notice that I've put in good descriptions for each of the fields. So for example, for the amount, I've put in something that says the amount involved in the transaction. Positive amounts represent money coming in, and negative amounts mean money going out. The reason good descriptions are important is that the AI will use them to understand additional context about your data. Transactions can belong to many different categories. So we've got transaction, and transaction can have many categories, and obviously a category can have many transactions. This allows me to group transactions into useful buckets like groceries, electricity bills, wages, things like that. Now let's have a go asking our AI about my transactions. So we'll switch over to the PromptQL tab here, and we've started a new chat. So let's ask it about my electricity bills. So looking at my previous transactions, starting from 2023, on what months do I usually pay electricity bills? And how much do I usually pay? Look for payments in the category electricity bill. I'll submit that. Now the AI has come back with a query plan, and it tells us exactly what it's going to do. If we want to see the specifics of how it's done this, we can open up this executed panel here once it's finished printing. And in here we can see the Python and SQL that it's written to actually do the computation. So this is useful because it means we can validate the AI's approach. We can see what it's done is it's pulled out some data, and it's stored what we call a memory artifact on the right hand side. So we can see that it's basically pulled out the average payment for each month, and then sort of grouped it up by month and said the number of payments. So we can look at the analysis that it's provided here. It's basically pointed out how many bills I've done, the months I've commonly paid in, the average amount, and it's pointed out that it's not strictly a monthly pattern. It could indicate bi-monthly billing. So that's pretty cool. So let's ask it about my internet bills in the same time period. So what about my internet bills in the same time period? Again, it generates us a query plan, and it executes it. And then when it's done, it should store some of that data in a memory artifact over on the right-hand side, which it's done. So we've got internet bills payment analysis. It's pointed out that I've made internet bill payments in all the 12 months. So yep, I haven't lapsed on my internet. We can see the average amount that I've paid, comparing internet bills with electricity bills. So it's actually done an analysis where it's compared internet with electricity, which is interesting. It says electricity bills are less regular. Internet bills are quite consistent. Internet's a clear monthly pattern. Internet is cheaper, unsurprisingly, than electricity. So that's pretty neat. Now let's try asking it about groceries. So we'll start a new chat. Please give an analysis of groceries costs over time starting in 2018. Look at transactions in the groceries category. So again, it creates us our query plan. When it will execute it, you can see what it's trying to do. It's going to calculate a total grocery spending, compute some basic statistics, and look at some trends. So we've got some monthly grocery spending stuff over here. So if we look at the analysis, it's basically said total spent, average monthly spending, year-on-year changes. It's pointed out a significant increase during the pandemic. Yeah, that would make sense, given that I was in quarantine at home during that year. There's an upward trend in grocery spending in the last 6 months. And it also noticed that there's a recent upward trend in the last 6 months suggesting grocery costs might be rising, which is interesting. That's probably due to all the food inflation prices. So that's very clever. So why don't we ask it about the most expensive transactions? Please look at the on average most expensive groceries transactions and see whether there are any patterns to be found there. It's going to pull out the top 50 most expensive transactions, look for patterns, calculate some stats, and then it'll stick the results into an artifact so we can browse it. And then give us an analysis. Oh, it's had an error. So this is one of the cool things about PromptQL. When it has an error, it basically looks at the error that it had and then tries to fix it itself, and we don't have to do anything. It will take care of itself. So it's looked at the error, adjusted the code that it's generated, and is trying again. This time it's worked. And let's see what the analysis that it's provided. So wait till it finishes writing. Okay, so it's looked at the average amount, the highest transaction, the most common year, most common month, most common season, summer. That's interesting. I guess it doesn't know that I'm in Australia, so that's really our winter. The most common day of the week is Friday, which makes sense because that's usually when I go shopping. If it looks at the descriptions and it notices that meat from the market tends to be the most significant expense, which tracks other things like supplements and probiotics. Additional observations, so meat from South Melbourne market, especially a high quality meat, a notable contributor for high grocery bills, makes sense. And it's given us a bit of a summary of patterns down the bottom, which is pretty neat. So as we've seen, it's trivially easy to get insight into your data using natural language with PromptQL. So this has just been a little taste of what's possible. I encourage you to give it a shot yourself and think about what sorts of cool things you can create with Hasura and AI. Thanks.
All right, folks. I think the most interesting thing that I learned from that is that Vegemite is nowhere in Daniel's monthly budget. That's surprising. There should have been a question there. Just if you're not sure what that is, Google it real quick. Australians love it. Everyone else in the world apparently hates it. But since we are talking about a taste for things and health and probiotics and all those fun things, Praveen, will you go ahead and join me on stage so we can take a look at your Apple Health data with PromptQL? How's it going, man?
All good, all good. Yeah, how's it going for you?
Just give us a teaser. Are you healthy or not? Like, what does PromptQL say?
We can find that out live, actually. That would be a good demo.
Yeah. All right, Dr. PromptQL. All right, I'm going to jump off the stage, let you take it away, and I'll see you at the end of your segment.
Awesome, cool. So I built this AI assistant for Apple Health data. So those who know me personally know that I'm a big health nerd, obsessed about the statistics and keep track of all the data that's there. So when I saw that PromptQL could just like connect this private data, like Apple Health data, the first thing that I did was just cleaned up my Apple Health data, exported it into Postgres. I could have done it to Mongo or any other data source as well, but it looks like Apple gives you like a very structured export in XML. So pretty easy to like dump it into like a Postgres database. So I did that first. So cleaned up the data, and this is what the schema looks like, a pretty simple table with just a few columns. And these are the different kinds of metrics that Apple exported for the health export. And you can see that it has like a lot of measurements happening across different categories. And this is my data set, right? It has a few million rows actually to analyze across different categories and different devices that are capturing this data. This data is now available. I have now connected Hasura DVN to this database. And as we saw from previous demos from Daniel and even Anshul through talking about Supergraph and how Hasura DVN connects to these data sources and exposes or gives PromptQL the ability to query data. I've connected to this data set, and I can quickly show you what I've added as description. I think Daniel had a slightly better description. I added basic descriptions for these columns of this health table, just the measurement, the timestamps, and the source of this data as well, right? So that's all this data. I've created a few views in Postgres so that it becomes easier to track and analyze some specific measurements. But broadly, this is the primary table which holds all this information. So I'm going to go ahead and ask the assistant what it can do actually, right? With the table information, PromptQL already understands that, hey, it is going to analyze health data, and it can provide insights on these different parameters, including sleep patterns, your heart rate, and other nutrition data and whatnot, depending on what devices you track with Apple. Cool. So let me begin by asking, what's my average walking per day? Consider, let's say, last week to see some recent data. And as you saw in previous demos, a query plan is formed initially. So like if I had to like find out this data myself and there's some database, I would do something like this myself, right? I would do like a date range, look at the right table to fetch this data, and then actually do the computation to find the averages and whatnot, right? And it looks like and I've gotten the response, and it looked like there are duplicate dates as well, and there are different sources that are actually tracking this data. So you would have your iPhone, you would have your Apple Watch, or other devices that are tracking this data, right? So I would just say consider single source of truth and aggregate data by the date, right? And I think this is happening because there's iPhone and there's also an Apple Watch and there's different sources tracking this data. Now with a single source of truth, we will actually aggregate all of this in one place. And it does this Python code, and obviously it failed for some data processing. So it again retried the right function, which is cool about PromptQL as well. Like it does it agentically, where it retries if something goes wrong and then actually executes the right query plan to get the final output. And as I can see here, I've gotten the aggregate data step counts for the last week. I can expand on this. Cool. So average seems to be pretty high. The fifth, when I was moving houses, there's just a lot of walking around. Cool. So now this is obviously like very simple data that you can already look at in your health app. So nothing fancy here. So let's make it a little more interesting. Maybe we can ask a very generic question. How is my heart health? Now this could mean a bunch of things. So the LLM needs to figure out what heart health means based on the schema that we have given. So it needs to find out data on resting heart rate variability, VO2 max, which is cardio fitness, and maybe even blood pressure readings if it's available, and like do some aggregates on top of this, right? So this is what the query plan looks like. It will try to fetch all of this data, and my question was very generic to just say, hey, how's my heart health, right? And it does this execution. There's a little bit of changes in the way it handles dates. So there's a couple of retries here. And we can see that it has produced like resting heart rate variability, oxygen saturation, and then it has come up with some averages for these values, right? Cool. So now let me also ask a slightly more complicated question. This was one of my favorites one. So based on my weight and BMR, tell me if I'm on track to lose weight and what should my calorie intake be for like losing 1 pound a week. Seems a lot, but let's see what PromptQL does. This would be something that I think would be very difficult to quickly analyze from my health app, because even though the data is there, even though I can see my BMR data over 3 months, I'll not be able to quickly tell what my expenditure is and what my calorie intake should be going forward to reduce this weight, right? And it looks like PromptQL has figured it out. It did query the basal energy bond table, average weight, and then it did some calculation to see how much should you lose for 1 pound a week. This is a Python program which does the computation, which makes all of this possible as well. So it took a calorie deficit of 500, which is for losing 1 pound per week, and it did some calculation and computation. And it looks like I have, I think, a BMR of 1,827 calories, and my recommendation is 1,320 something. So here you go. I think this is pretty interesting to understand based on what PromptQL is able to do. Let's do one more quick question. And this is another interesting question, which is not very easily available to analyze from your health app. How much time am I spending outdoors? And some of you probably even wouldn't realize that this is data available on Apple Watch and iPhone if you're just spending outside with daylight. And we can find some interesting patterns. And I can see that my average daylight exposure is like 36 minutes across probably the last 2 days. I think it's taken the recent time. And the maximum daylight exposure is like 127 minutes, like for more than 2 hours, I think. Now let's ask it to find patterns for outdoor time spent over the last year. And let's see what it does. So the last question was around for a 1 month data set. If we take it for a slightly longer period, we can find some interesting patterns to see what I've done. And again, as usual, there's a query plan. And interestingly, it has tried to find like weekday and weekend patterns, monthly and whatnot. Cool, so it has stored this artifact of raw data here. And what does it say? So your outdoor time significantly increases during summer and spring, which makes sense. And obviously, we locked out at home during winter, lowest in December. SF winter is not too bad, but it still makes me be at home. So yeah, these are cool insights. And now you have access to this data set, so you can now start asking any cool about your health and then play around with this data, which you wouldn't have otherwise just with your Apple Health app. Yeah, that's for my demo.
Praveen, that was great. Thank you so much. If you want to unshare screen just real quick, maybe one question for you before I throw you off when we finish up the call. If we're talking about so we actually do have a question that just came through. So do you think storing Apple data in an unstructured or semi-structured format, such as a nested MongoDB collection, might introduce challenges for PromptQL in terms of semantic understanding and efficiently traversing the data hierarchy? I'm going to pause there and let you answer that question, and then we can come to the second part of the question too.
Yeah. So I think, and this is very like looking at Apple's XML structure itself, it's pretty straightforward set of fields. I think probably like 6 fields around there, and looks more structured. Even if you dump it into Mongo with whatever nesting you would want, it should be fairly easy to query that data. But outside of this particular schema, I think if you dump it into Mongo or slightly complicated nested schema, I think the query plan would make sure that PromptQL executes the right query on Mongo, gets the data, processes it in Python to compute. The good thing about PromptQL is that it has Python runtime to do further computations, even if Mongo or your underlying source is not able to do that. Which means you can fetch the data, do computations in Python without passing it in the context of the LLM, which opens up a lot of possibilities and lots of use cases. So I wouldn't say it would be a problem for Mongo as well.
Yeah, definitely. I think that addresses the second part of the question as well, which is kind of on the performance and the accuracy of that really deeply nested content. So that should take care of that as well. And just to point out what you're saying as well, right? The query plan, there's full transparency of what's actually being run. So if you are curious as to the validity of the data itself, if you wanted to, right, you could take that that Python and do your own things with it. Yeah. Cool. One question that I was going to ask, just because I don't see any other ones that are coming up right now. Just double checking to make sure. Yeah. Maybe a theme for the demos that we've seen today is really kind of structuring, kind of padding your data sources with context, because that's all essentially getting sent to the LLM so it understands what's going on. That can take different forms, right? We can have descriptions of different models that are coming in as tables or whatever they may be. But also, like as an example, I know that I've used the TypeScript connector that we have for Node.js. So could you just tell people, like, if they're using one of these connectors, how can they actually pad more context for the functions that are exposed in the API?
Yeah, and again, this is enabled with Hasura metadata. And for those who are familiar with Hasura, worked with Hasura before, Hasura maintains a metadata about all your data sources, including your schema, including your APIs, and it's represented as models and commands. You could add additional description for each of those fields in your models and commands, and then just give it more context to the LLM as well. And as we saw in Daniel's demo and my demo as well, we added very simple descriptions to help the LLM understand what these columns mean, because sometimes database columns could be very cryptic, right? So it's good to like add this additional context through description and just like bunch of YAML configuration.
Awesome. Praveen, thank you so much. I hope Ifrithra feeds you some good food and we see, you know, the pounds coming down or coming up depending upon what you're after. So to you and your health, the best to you. I'm going to go ahead and I think you can head off stage, and I'm going to share my screen one last time to finish this call out. We're almost on time for our conclusions today, so just after the top of the hour here. As a reminder, our community, we have Discord office hours every Tuesday at 10 a.m. Pacific. We also have a Discord server that you can join and just throw in questions for either help with Hasura DDN, PromptQL, or Hasura V2. And you can check out, you know, product updates that come through there just to stay up to date with everything DDN and PromptQL related. Additionally, just some helpful links for you. We're always open to feedback and looking for information about how we can better help you. So you can see all of our choices right there. Typically on these calls as well, we'll have community contributions or community demos. So if you're interested in presenting in one of these calls and getting a shout out and kind of promoting the work you've been doing with Hasura or with PromptQL, we'd love to have you on. Otherwise, thanks for joining us. Have a great end to 2024, and we will see everyone at the next call in 2025. Bye, folks.